Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue the same module, that is a database design concepts, and the new chapter, that is a new part, that is a part number 5, system architecture. In the last class we have finished with chapter number 16, that is a recovery system, and the part number 4 also. Now next is our system architecture, that is a part number 5. So let's start with the part number 5. Let's start with the chapter number 17 onwards. So first of all, what is the part 5? That is system architecture. That is, what is the system architecture, how to maintain the architecture of a system, or we can say what is the structure of the system, what is the boundaries of the system that is available in the system architecture. So the architecture of a database system is greatly influenced by a underlying computer system on which the database system runs. So the architecture of a business or architecture of a database system is greatly influenced by the underlying computer system. So whatever the computer system that is available, that is underlying in the argument system, that is underlying in the computer system on which the database system runs. Database system can be centralized. So whatever the database system that is available, that is centralized systems. So that means every software, every computer is available online, that is on a centralized location, where one server machine executes operation on the database. That is, one server machine executes operation on the database, and all the clients, all the computers are following that server. Database system can also be designed to exploit the parallel computer architectures. Distributed databases can span multiple geographically separated machines. So there are distributed databases that are available, that can disperse the database, that can disperse the data online geographically in a separated machine in a various separated parts. That is, it can span the multiple geographically separated machine. That is, it can separate the part, it can separate the multiple, we can say the parts that is beyond the boundary that is available in the geographically segregated countries. Now, chapter number 17 first outline the architecture of a database system. That is, what is the architecture of a database system that is running on the server systems, which are used in the centralized and the client server architecture. The various processes that together implement the functionality of a database are outlined here. The chapter then outlined parallel computer architecture and the parallel database architecture that is designed for different types of parallel computers. Finally, the chapter architecture issues in the distributed or building a distributed database system. Then chapter number 18 that describes how various actions of a database in a particular query processing can be implemented to exploit parallel processing. Then chapter number 19 that presents a number of issues that arise in a distributed database and describes how to deal with this issue or how to deal with each issue. That is chapter number 19. Chapter number 17 means architecture of a database system, 18 means various actions of a database, 19 means various issues that arises in a distributed system. So let's start with the chapter number 17, that is the database system architecture. That is, what is the database system architecture? So architecture means whatever the architecture, whatever the structure that we are using, that is the architecture of a database. Architecture of a database system is greatly influenced by the underlying computer system on which in turn or which it return or which it gives the output capacity, that is it is outputted by the underlying computer system on which it runs, in particular by such aspects of a computer architecture such as the networking, parallelism, and the distribution. So these are the few concepts that is used in this one, that is a parallelism, that is a distribution, and the networking. So first of all, what is a networking? So these are the various aspects of the, we can say the networking, these are the various aspects of the architecture. So first is the networking. That means whenever we combine multiple computers together, that is a networking. So networking allows some tasks to be executed on a server system, that is tasks to be executed on a server system and some tasks to be executed on the client system. So some tasks is available on the server system and some task is available on the client system, and they are made available to form the various client to form the various role to perform the various operations. This division of work has led to the client server database system. That is, whenever we divide the work among the server and the client, that is known as the client server database system. Parallel processing within a computer system allows database system activities to be speeded. Processing parallel systems or the parallel processing within a computer system that allows the database system activities, that is more than one database activity or more than one database is used with a faster response to the transaction as well as the more transaction per second. So every transaction is executed at the same time as well as the more and more transaction is executing to the response time, that is a parallel processing. Queries can be processed in a way that exploits the parallelism offered by the underlying computer system. So whatever the query that is used, whatever the processing can be used, that can be processed in a way that exploits the parallelism offered by the underlying computer system. The need for the parallel query processing has led to the parallel database system. So whatever the need, whatever the parallel query processing, that has led to the parallel database systems. Next is the distributing data across sites in an organization that allows those data to reside where they are generated or most needed. So whatever the data, whatever the distribution that occur, that arise mostly in the sites of in an organization, that allows that the data to be resides when they are generated or where they are generated. That means how to distribute the data, how to merge the data, how to make the data distributable among the various sites in the organization, but still to be accessible from other sites and from other departments. Keeping multiple copies of the database across different sites also allows a large organization to continue their database operations even when one site is affected by the natural disaster. That means the data will be distributed among the various components, so that if one site failed, then the another site can continue the data, or is not affected by the natural calamities, and we can access the data among the different sites that is available, such as the fire, flood, or the earthquake. Distributed database system handles geographically or administratively distributed data spread across multiple database systems. So whenever we use the distributed database, that means geographically they are available, or geographically the data is spread over to the multiple database system. We study the architecture of database system in this chapter, starting with the traditional centralized system, that is covering the client server, parallel, and the distributed database system. So in this we are covering three types of database system. One is the client server database system, one is the parallel computing database system, and one is the distributed database system. So these are comes under the three part, that is the networking, parallel, and the distributed database system. Uh, then 17.1 is centralized and the client server architecture. That is, what is a centralized system and what is a client server architecture system, or how they are used as a client server architecture system. So the first point says centralized database systems are those that runs on a single computer machine. So when data is available, or whenever the data is available on a single multiple computer, that is known as the centralized system. That is, the data is available at the central location, and that is distributed among the various locations in the database system in the processing system. Centralized database systems are those that run on a single computer system, and do not interact with other computer system. That is, they do not interact with another computer system. They works only on a single computer system. Such database systems span a range from single user database systems that is running in the on a personal computer, to high performance database system running on a high-end server system. That is, they are running on the single server computer system, they are running on the high-end server systems. Client server system, on the other hand, has functionally split between the server system and the multiple client system. That is, client server architecture is also divided into two parts. One is the server system, one is the client system. Now the first part is centralized system. That is, what is a centralized system that is available. So a modern general purpose computer system consists of one to a few processor and a number of devices that controls, or number of device controllers that are connected through a common bus that provides access to the shared memory. So centralized means everything is available at the centralized location, and the information that is available at the central location will be passed to the another location one by one, or through a common bus that provides us shared access to the, or that provides access to the shared memory. For example, this is the diagram that is given. This is the centralized computer system. This is the CPU. This is the USB controller. This is the disk controller. This is the graphics adapter. There will be a memory that is distributed via the line, via common bus, that is distributed among the CPU, disk controller, USB controller, and the graphics adapter. So first is the CPU, then there will be a disk controller, that is a different disk, then there will be a mouse, that is a USB controller that is available, like mouse, keyboard, and the printer. Then there will be a graphics adapter that is available, for example the monitor, that is a graphics adapter. So first is a centralized system, that is a modern general purpose computer system consists of or to a few processors and number of device controllers that are connected to a common bus. The processor have a local cache memory that stores local copy of the parts of the memory to speed up the data access to the data. So they have a different processor, different CPU have a local cache memory. They have a different local cache memory that stores the local copies of the part of the memory. That is, there are different parts of the memory that is available, that is used to speed up the data, that is used to speed up access the data. And each processor may have several independent cores. So there are multiple independent cores that is available, each of which can execute a separate instruction stream. So whenever we are using the processor with the different cores, independent cores, each of which can execute a separate instruction stream, that is, there are different streams that is available, and each device controller is in charge of a specific type of device. That is, every charge or every controller has a different devices that is available that have a different processing schemes. Cache memory reduces the contention for memory access. So whenever we use the cache memory, it reduces the contention, that is how to use the memory access, since it reduces the number of times the processor needs to access the shared memory. We differentiate two ways in which computers are used. One is a single user computer, one is a multi-user computer. So there are two types of computers. One is a single user computer, one is a multi-user computer. Personal computer and the workstation computer falls in the first category, that is a single user computer. That is a personal computer and the workstation computer. So single user computer is a desktop unit that is used by the single purpose. That is for example, I am using my laptop. No networking, nothing sharing. That is a single user system. That is usually with only one processor and one or two kind or hard disk, and usually one person using the machine at the same time. That is, at the same time only one person is using the same machine. A typical multi-user system, on the other hand, has more disk and the more memory and may have multiple processor. That is, they have the more disk, more memory and the multiple processor. It serves a large amount of users who are connected to the system remotely. That is, there are multiple systems that are connected to the remote system, that is connected to the system in a remote manner. That is, they are available in the remote manner. Then database system that is designed for use by single user usually do not provide many of the facilities that is available. In particular, they provide the concurrency control, they provide the QBE, it provides the disk success, or it provides the disk controller. And they are designed for the multi-user systems also that supports the full transactional features that we have studied earlier. Although most general purpose computer systems in use today have multiple processors. So there are multiple processors that is used. So there will be a general purpose computer system in use today have multiple processors, and they have a coarse granularity parallelism. That is, there are multiple parallelism that is available with only a few processors, about 2 to 4 typically. There are multiple processors that is available, that is around from 2 to 4. So in a parallelism, there are 2 to 4 processors that is available, all sharing the main memory. Databases running on such machines usually do not attempt to partition a single query among the processor. So whatever the databases that is available on the machine usually do not attempt to partition a single query that is available among the processors. Instead, they run each query on single processor, allowing multiple queries to run concurrently. That is, there are multiple processors, there are multiple queries that is available, that allows the data to access, that allows the data to run in a concurrent manner. Therefore, such system supports a high throughput, that is, they allow a great number of transactions to run per second. That is, individual transactions do not run any faster. And database designed for single processor machines already provides multitasking that allows a multiple processor, that is more than one processor are used, more than one CPU is used for processing the database concept. In contrast, machines with fine granularity parallelism have a large number of processors, and the database systems running on such machine attempt to parallelize single task. So there will be a parallel task that is available, that is used to provide the parallel mechanism that is used to provide the single task that is submitted by the user. Parallelism is emerging as a critical issue in the future design of a database system. So whatever the critical task that is available, that is a critical issue that is available in the future design of a database system. Whereas today, those computer systems with multi-core processors have only a few cores. So whatever the system that is available, they have more cores, they have a few more data that is available in the database systems. Now, Next is the client server system. That is, what is the client server system? How to use the client server system. So as personal computers become faster, more powerful and cheaper, there was a shift from centralized system to the personal computer. So there is a shift from the centralized system to the personal computer that is used in a variety of content, that is used in a variety of matters. So a personal computer become faster and the powerful, that is used, that is there are shift from the centralized system to the multiple computers. Personal computers supplemented terminals connected to the centralized systems. Correspondingly, personal computers assume the user interface functionality that used to be handled directly by the centralized system. As a result, centralized system today acts as a server system that satisfies the users, or that satisfies the request that is generated by the client system. So whatever the client system they are generated, they are contacted with the server systems. Functionality that is provided by the database system can be divided into two categories. So there are two categories that is provided by the functionality that is provided by the control system, database system, that is the front end and the back end system. The backend manages access structures, query evaluation and the optimization, concurrency control and the recovery. The front end, this is the backend that manages the structures, query evaluation, optimization, concurrency control and the recovery. And the front end that consists of the tools such as the SQL user interface, report generation tool, data mining tool, as well as the analysis tool that is available in the client server systems. The interface between the front end and the back end is through the SQL or through an application program. So the front end and the back end tool is available, that is available through the SQL or through the application program. This is a server. These are the different clients that is connected to the single server. Everything is available on a single server. And standards such as the ODBC, that is the Open Database Connectivity, as well as the Java database connectivity, that is also available in the Java content, that is also available in the to interface or provide the interface with the different servers. Some transaction processing systems provides a transactional remote processing call interface to connect clients with the server. These calls appears like ordinary procedure calls to the programmers, but all the remote procedure calls from our client are enclosed in a single transaction at the server end. So whatever the server procedure, whatever the server content that is available, that is enclosed in a single server. Therefore, if the transaction aborts, the server can undo the effects of the individual remote procedure call. So whatever the transaction aborts, or whenever the system aborts, transaction aborts, the server can undo the effects of the individual procedure call. Now next is the server system architecture, that is what are the system or what are the server system architecture that is available. The server system can be broadly categorized as a transaction server and the data server. So whatever the server system that is available, that is divided into the two parts, that is the transaction server and the data server. So server system is divided into transactions as well as the servers or data servers. So this is the SQL engine that is available. There is a SQL user interface. This is the forms interface, report generation tool, data mining and the analysis tool. This is the front end, and this is the interface, and this is the back end. This is a system that is used, that provides the front end and the back end functionality. So there will be a functionality that is available, that is the front end and the back end functionality. So this is a SQL user interface, this is the forms interface, this is the report generation tool, data mining, that is the front end, and the back end there will be a search or SQL engine, and there will be an interface. So transaction server systems, also known as the query server system, that provides an interface to which clients can send the request to perform an action. That is, client gives a request to the server to perform some actions, in response to which they execute the actions and send back the result to the clients. Usually, client machines ship transaction to the server systems, where those transactions are executed and results are shipped back to the clients that are in charge of displaying the results. So the client gives a request to the server, and server provides the services to the client. Request may be specified by using SQL or through a specialized application program interface. So whatever the request that is supplied by using the SQL or through a specialized application program interface. So the first one is the transaction server system. Next one is the data server systems. So the data server system allows the clients to interact with the server. So whatever the system that is used to interact with the servers by making the request to read or update the data. So these allows the clients to interact with the server that allows the request to read or update the data. Any units such as the files or the pages. So whatever the data server system that is available that is used to provide the request to read or update the data. For example, file servers provides a file system interface where clients can create, update, read and delete the files. That is, file servers provide the clear update provide the file system interface where the clients can create, update, read, delete and delete the files. Data servers for database systems offer much more functionality, that is they support units of data. So there are different data that is available that is used to provide the different database servers. Of these, the transaction control or transaction server architecture is more widely used architecture as compared to the data server architecture. Now first is the transaction servers. So a typical transaction server system today consists of multiple processing accessing data in a shared memory. So whatever the data that is available, that will be available in the shared memory. The processes that forms part of the database system includes server processes, that is the transaction server. So the first one is the server processes, that is a process that is maintained, that is a server processes. So these are the processes that requires or receives user queries, that is the transactions, executes them and sends the result back, that is the server processes. The queries may be submitted to the server processes from a user interface or from a user interface that is running embedding SQL via JDBC or DBC or the similar records. Some database systems use a separate process for each user session. So there will be a separate system for each user sessions and they provide the single database connectivity for the different sessions but with the multiple threads, so that multiple queries can execute in a concurrent way. That is a server process. That is a multiple queries can be executed in a multiple processes that is used. So thread is a process that is currently going to execute the process, that is multiple processes can execute like a thread. And all the threads within a process run in the same virtual memory space. That is every thread that is available in the virtual memory thread. Multiple threads within a process can execute simultaneously. Many database systems uses a hybrid structure. So there will be a hybrid structure that is available that is used by the database systems with multiple processes, each one running multiple threads. So everyone running or everything is running on a multiple threads, that is a server processes, or that is a thread. Next is the log manager process. So one is the server processes, one is a log manager process that implements the log manager functionality. So whatever the log manager functionality that is available, that includes the grant log or the log grant, log release and the deadlock detection. That is when to grant the log, when to release the log and when to detect the deadlock. That is what are the different functionalities that is available in the granting, that is available in the logging system. That is the granting the log, releasing the log and provide the functionality to the different logging systems. The next is the database writer process. So next process is the database writer process that are used to allow different one or more processes that output modified buffer block back to the disk on a continuous basis. That is whatever the content that is available, they provide the database access, they provide the continuous approach, that is provide the output modification to the different databases on the continuous basis. Then next is the log writer process that outputs the log records from the log records buffer to the stable storage. That is the log writer process. This is a user process, that is a user process. This is a server process, this is a server process. Then there will be a transaction process, buffer full, query plan cache, log buffer, log table. These are various processes that is available. One is the ODBC, then there will be a JDBC. And these are the log disk, these are the data disk. That is the shared memory and the process structure. Then next is the checkpoint process. This process performs periodic checkpoint. So whatever the checkpoint that is available, that ensures the periodic checkpoint that is used in the checkpointing process. Then process monitor process, that is how to monitor the processes, or how to monitor, or what is the procedure to process the monitor, that is a process monitor process. This process monitors other processes, and if any of them fails, it takes recovery actions for the process, such as aborting the transactions, failing the transaction, or restarting the transactions, or restarting the processes. The shared memory contains all shared data, such as, so what are the various data that is available? One is a buffer pool, then log table, then log buffer that contains the log records waiting to be output to log on the stable storage. And the cached query plan that is reused if the same query is submitted again. Now all the database processes can access the data in the shared memory. So every database process that is available can access the data in the shared memory. And since multiple processes may read or perform update on the data structure, in shared memory there will be a mechanism, or there must be a mechanism, to ensure that the data structure is modified by at most one process at a time. So this is modified by one process at a time, and the no process is reading a data structure while it is written, or while it is being written by the others. Such mutual exclusion can be implemented by means of the operating systems. So to avoid the overhead of message passing in many database systems, server processes implements logging by directly updating the log table instead of sending the log request to the log managers. Then there will be data servers. The database or data server systems are used in the local area network. So these are generally used in the local area network, that is a LAN cable or LAN networks, where there is a high speed data connection that is between the clients and the server. So there will be high connection that is maintained between the client and the server. Client machines are comparable in processing owner prior to the server machines, and the tasks to be executed are computation intensive. In such an environment, it makes sense to ship the goods or data to the client systems and to perform the processing at the client machines. Database architecture is available in the, or discussed in chapter number 22 in a detailed manner. Interesting issue that arises in such an architecture is available, since the time cost of communication between the client and the server is high compared to the local memory reference. So interesting issue is that whenever we use the architecture that is available, so the response time or the time cost that is available, that is high as compared to the local memory reference, that is a milliseconds versus less than 100 nanoseconds. Now next is the page shipping, that is what is the item shipping, that is what is the difference between the page shipping and the item shipping. So the unit of communication for data can be, of course, granularity such as page, or fine granularity such as tuple. In the content of an object-oriented database system, we use the term item to refer to the both tuples and the objects. In the unit of the communication in a single unit, the overhead of the message passing is high as compared to the amount of data that is transmitted. So whatever the amount of data that is transmitted, that is high amount as compared to the page shipping. The next is the adaptive log granularity. So logs are usually granted by the server for the data item that is shipped to the client machines. A disadvantage of page shipping is that client machine may be granted logs of 2 cores granularity, a log on the page implicitly that is used for the database systems. So next is the adaptive log granularity. That is how to use the adaptive log granularity. That is granularity. That is logs are usually granted by the server for the data item that is shipped to the client machines. A disadvantage of page shipping is that client machine may be granted logs of 2 cores granularity. That is a log on the page implicitly logs all the items that are contained in the page. Even if the client is not accessing some items on the page, it has implicitly required the logs on all the prefetched items. So whatever the item that is available at the prefetched items. Other computer or other client machine that requires the logs on those items that may be blocked unnecessary. So provides the logging on the system that are blocked unnecessary. Techniques for the log escalation have been proposed, where the server can request its clients to do transfer backlogs on prefetched system. So whatever the prefetched system that is available, they can they can block the system, they can use the system, that they can transfer the backlogs to the prefetched items. if the client machine does not need a prefetched item. So if the client machine does not need a prefetched item that is available, it can transfer the log on the item back to the server, and the logs can then be allocated to the other client. That is whatever the log that is available, they are available on different clients. Next is the data caching. That is how to use the data caching. What is the requirement of using the data caching? Data that are shipped to a client on behalf of a transaction can be cached at a client. So they are available at the client. They are available at the client machine. Even after the transaction completes, if sufficient storage space is available. So if there is any storage space that is available, they can access the data. They can use the data, and they can provide the data in a specified manner. So that is the data caching. That is provide the caching technique, provide the various technique that is used, that is available in the data expires. And there will be cache coherency. That is an issue. Even if a transaction finds the cache data, it must be take sure that the data are up to date, that is available in the data accessed. Therefore, the message must still be exchanged with the server that is available to use the data available that is used to get the data content available. Then next is the log caching. That is also provide, there is also provide the facility that is used for the locking the caching memory, that is the log caching memory. So if the use of the data is most persistent among the clients rarely requesting the data that are also requested by the clients. Log can also be cached at the different clients or at the client machine. So whatever the logs that is available, they are logged on the different machine, they are logged on the client machines. Suppose that a client finds a data item in the cache, it also finds the log required for the access to the data item in the cache. Therefore, the access that is can be processed without any communication with the server. So whatever the communication that is provided, they are provided with the different communication that is provided with the database servers. Then the access can proceed without any communication with the server. So whatever the access that is available, whatever the content that is available, they can access the availability content that is available in the database system. The task become more complicated when the machine failures are taken into the account. So whatever the machine failure that is taken into the account, that will complicate their data, that will complicate the content of the data. This technique differ from log discorrelation in that log caching takes place across the transactions. Otherwise, the two techniques are similar. The next is the cloud-based server. That is how to use the cloud-based server. What are the various techniques that is used in the cloud-based servers? So servers are usually owned by the enterprise providing the services, but there is an increasing trend for the server providers to rely at least in part upon the server that are owned by the third party. So whatever the server that is owned by the third party, that is neither the client server, that is neither the service provider. There is no server, that is not the client, nor the service. One model for using third parties outsource the entire service to the another company. That is the next part. There's one of the model that is available for the third party server. So one of the model that is used, for example, third party server that is used to outsource the entire service to the other company, that is providing the entire services to the another company that hosts the service on its own computer using the nodes software. This allows the service provider to ignore more details of the technology and focus on the marketing of the service. That is, there are different service providers that is using the technology that provides the details of technology and focus on the marketing. What is the marketing strategy? What are the various issues that is available in the marketing strategy? Another model for using the third-party server is the client computing. This is the next third-party server that is available, that is known as the cloud computing, not client. This is the cloud computing, and with the service provider runs its own software. That is, there are different software that is running by the service provider itself, but run it on computers provided by another company. So whatever the company that is provided, they are provided by the server company or different companies. Under this model, the third party does not provide any of the application server. It provides only a collection of machine. That is, there is no collection of the machine, there is no application server that is used, but it provides only a collection of the machines. These machines are not real machines, but rather simulated by software that allows a single real computer to simulate several independent computers. So there are different independent computer that is available. They are not the real machine that is used with the virtual machine. And such simulated machines are known as the virtual machines. The service provider runs its own software. There are multiple software that run by its own, that is possibly using the database system on these virtual machine. A major advantage of cloud computing is that the service provider can add the machines as needed to meet the demand. So whatever the content that is available, that is added the content, that is added the add the machine by the service provider to meet the requirement of the load, to meet the requirement of the system. This can prove to be highly cost effective in terms of both the money and the energy. That is, it can be save the energy, it can also save the money. A third model that uses the cloud computing as a data server, such as the cloud-based data storage, that is covered in the 19.9, that is in the 19th chapter. Now, next come to the parallel system. So we are finished with the client server systems, in which there is a client and there are different, in which there is a server and different clients are available, and the server can contact to the different clients. So next is the parallel systems that improves the processing and input output speed by using a multiple processors and disk in parallel. That is, there are different processors that is available, and there are different techniques that is available to provide the disk access. Parallel machines are becoming increasingly common and making the study of parallel database systems correspondingly more important. So there are multiple systems that is available that provides the database in a consistent manner. The driving force behind this parallel database system is the demand of the application that has to query extremely large database. So there are multiple large database that is available that process the query in extreme large databases, for example, in terms of the in order of the terabyte, that is 10 power to 12 bytes, or have to process an extremely large amount of or large number of transactions per second. Centralized and the client server database systems are not powerful enough to handle such applications. So whatever the centralized system, whatever the client server database systems that are not powerful enough to handle the application. In parallel processing, many operations are performed simultaneously. So in parallel processing, whenever there will be a parallel processing, many operations are performed in a simultaneous way. That is, multiple operations are performed simultaneously as opposed to the serial processing, in which the computational steps are performed sequentially. That is, there are multiple sequence steps, there are multiple computational steps that is available that are performed sequentially. A cross-grain parallel machine consists of a small number of powerful processors. A massively parallel or fine-grained parallel machine uses thousands of smaller processors. Virtually all high-end machines today offer some degree of coarse-grained parallelism, at least 2 or 4 processors. So there are multiple processors that is available. That is, in our system there are multiple computers. There are parallel computer that is available in parallel machines. Massively parallel computers can be distinguished between the coarse-grained parallel machines by the much less larger degree of parallelism that they support. And there are two measures of performance of a database system. That is, there are two parts by which we can measure the performance of a database system. That is the throughput and the response time. So one is the throughput, that is how much is the throughput, what are the various number of tasks that can be completed in a given time period. So what are the various tasks that is available in the given time period. And next is the response time, that is the amount it takes to complete a task. So one is the throughput, that is that means the output, that the how many number of tasks that is completed in a given time period or given time interval. And next is the response time, that is how much the time required to complete a given task from the time it is submitted, that is the response time. A system that processes a large number of small transactions can improve throughput by processing many transactions in the parallel. So it can process the transaction in a parallel. A system that processes large transactions can improve response time as well as the throughput by performing subtasks of each transaction in parallel. So whatever the system, whatever the process that is available, they can contain the large system in a database system, they can maintain the large system in a database system to improve the efficiency of a transaction managing scheme that is available in the parallel. The next is the speed up and the scale up. So there are two issues that is also available. Different issues that is available in the parallelism are the speed up and the scale up. Running a given task in a less time by increasing the degree of parallelism is known as the speed up. That is running a given task in a less time. That is the same task can be carried out, the same task can be achieved in a less time by increasing the degree of parallelism, that is known as a speed up. And handling larger tasks by increasing the degree of parallelism. So handling the multiple tasks that is increased or that is used by increasing the degree of parallelism, that is known as the scale up. Now consider a database application running on a parallel system with a certain number of processors and the disk. So this is one of the examples. So consider a database application, any database application that runs on a parallel system with certain number of processors in the disk. Now suppose we increase the size of the system by increasing the number of processors, disk and other component of the system. The goal is to process the task in time inversely proportional to the number of processes in the disk allotted. So whatever the disk allocated, whatever the number of processes that is available, they are inversely proportional to the number of processes in the disk allocated. Suppose that the execution time of the disk on the larger machine is TL. So suppose this is the time that is available, that the execution time is the same task is available on the smaller machine, that is the TS. The speed up due to the parallelism is defined as TS and the TL, that is TS is divided by the TL. And the parallel system is said to be demonstrate linear speed up if the speed up is n when the larger system has n number of resources. Scale up relates to the ability to process larger tasks in the same amount of time by providing more resources. That is, the scale up means adding the more task, adding the more functionality. Let Q be a task and Qn be a task that is n times bigger than the Q. Suppose that the execution time of a task Q on a given machine, that is, there will be execution time that is available on the Q. So this is a linear speed up and this is a sublinear speed up. This is a speed up with the increasing resources. This is a linear speed up and this is a sublinear speed up, where TS and the execution time of the disk, that is a Q1 on a parallel system, that is a ML, that is n times larger than the MS, that is a TL. The scale up is defined as a TS divided by TL. The parallel system ML is said to demonstrate linear scale up on the task Q if TL equals to TS. So whatever the linear scale up that is available, they can provide the facility, they can demonstrate the facility that is available, that is the TL equals to TS. And if the TL is greater than TS, that is used to demonstrate sublinear scale up. And there are two kinds of scale up that are relevant in parallel database system depending on how the size of the task is measured. It depends on the size of the task that is measured. It depends on the different activity that is available in the different activities or that is available in the different tasks. So there are two kinds of scale up that is available. One is a batch scale up, one is a transaction scale up. In a batch scale up, there are multiple tasks that are assigned that depends on the size of the database that is available, that is a batch scale up. And the transaction scale up, that is a multiple transactions are submitted to the database that increases and the size of the database that is proportional to the transaction rate, that is the transaction scale up. And scale up is usually the most important metric for measuring the efficiency of the parallel database system. And there are a number of factors that against or that is used against the parallel operation that can demonstrate or that can affect the different speed up and the scale up operations. So one is the startup cost. So there will be a startup cost that is available that is associated with initiating a single process. So there will be startup code that is used, and a single processing consisting of thousands of processes, the startup time may overshadow the actual processing time, affecting the speed up adversely. That is a startup cost. And the interference means since processes executing in the parallel systems often access shared resources, a slowdown can result in different processes from the interfere of the resources that is available that can compete with the existing processes that has commonly held resources such as a system bus, shared memory or even logs. Then there will be a skew, that is breaking down the single task into the multiple steps that can reduce the average step, that is known as the skew. Now next is the interconnection network. So there are different networks that are interconnected with each other that I'm going to start in the next class. So because there is no student in the today's class, so that's all for today's session. In the next class I'm taking your next topic, that is your interconnected networks or interconnection of the different networks. So that's all for today's session. Thank you so much everyone for listening me, and if there is any doubts, any suggestions, you can ask the doubts from me. Thanks a lot everyone. Bye bye.